people. So real quick, a recap before we get back in and finish the quiz, because we're about ready to finish the quiz for sure. Question came up, can we simply write P equals little p, that we're trying to estimate, equals, and then the parentheses in the confidence interval? Great question. This is a better way of thinking about what a confidence interval is. So the confidence interval that you get, right now at any rate, is p hat plus or minus the margin of error. That's what you're getting coming to you. Now your TI doesn't give it to you in that form. Your TI gives it to you in the form p hat minus the margin of error, comma, p hat plus the margin of error. And that's what, depending on what software you use, what technology you use, it's going to do one of those two things, depending on which one you use. I don't know which one it's going to choose. So how do you get both the parameter value p and the margin of error into the same mathematical symbolic sentence, if you so choose? And I think this is a great idea because it is concise to do it that way. The quick and easy answer is you can't just do that. You have to say, I'm going to put 95%. I'm 95% confident that, and here's a really foolproof way of talking about where little p is with respect to the margin of error and the interval. You put p in here, surrounded by inequality signs, put the low end here, and put the high end here. That's an inarguable mathematical statement. Because you covered yourself by saying I'm 95% confident. There's a chance it's below the low end or above the high end, 5%. In total. You don't exactly know where, but 5% in total. So that's a safe way, and thank you, Dan, for bringing that up. That's a safe way of comparing where the parameter most likely is to where the sample statistics are. I wish they didn't use p and p hat. You know how x bar and mu are used? I like that because they're very different. Mu is different than x bar. I wish they used like, p and f or something like that for fraction. I don't know. But they don't. They use p hat. Some books use p star. But we're stuck with it. We're stuck with that language, which is unfortunate, but whatever. We're stuck with it. We'll learn it. Connor, go ahead.
Yeah, wouldn't it be less than or equal to and greater than or equal to?
Now we're getting into continuous versus discrete. And you're correct if it was discrete, but it's continuous data. And when we answer Roy's question, we'll answer why it's continuous and not discrete momentarily. Because Connor's thinking, what the hell are you talking about? It's continuous. We're talking about the binomial distribution, right? 1, 2, 3, 4. It's not continuous. But we're making a continuous assumption based on the fact that it's a z-curve. So that's why it doesn't matter. You can put it there and you're not wrong. You could not put it there and you're not wrong. So yay, we're safe. Yeah, good. Other questions? These are great, like get in deep questions. I love them. Anything else so far? We're gold? We're gold. Okay, good. Let's answer the last question. Then move on to some theory and a little tiny bit of algebra, even though Chris doesn't want to hear it. I apologize.
When you
Chris, go ahead. You're processing this. I'm sorry.
Can't you just say, 7.3% plus or minus 2%?
Of course. The question was, how does little p relate to that?
Oh, I see.
That's the question, is how to get little p into the same mathematical statement as p hat. Of course you can say that, as long as you also preface it with I'm 95% sure in this result.
Right.
But yeah, nothing wrong with that at all. That's the top up there. It's just if you want to talk about where the little p parameter most likely is, you want to kind of write it like that.
Okay.
Is that fair?
But when you say plus or minus 2% or something like that, does that imply 95%?
By common usage, yes, because that's the most common confidence used.
Okay.
It also implies in a statistician's mind that 95% of the time that's where little p is. The question is, how can you explain? I always like to think about this. How could you explain this to a coworker? How could you make the news make sense to a coworker in using what we're discussing in class? So rather than filling our minds with a bunch of math-ese, let's try to break it down into language. So if you could make them understand what the difference between p and p hat is, and if they knew what inequality signs are, you could explain this to somebody. You'd be like, oh, okay. It's like I'm throwing a net at an animal I can't see. The animal is little p. The net is the thing determined by these two endpoints. I'm throwing it at that animal, sort of blindly, but I'm getting good random samples of where the animal is, ha, 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 I'm gonna catch it 19 times out of 20. Somewhere in the net. It might be at the very end, like C-3PO in Return of the Jedi. It might be right in the middle, like a bullseye. You know, who knows where it might be, but it's gonna be somewhere in there 95% of the time. Is that fair? I always like to think of it in non-mathematical terms because, face it, we live in a world that's non-mathematical. We are not non-mathematical, but the world we live in very often is. But it pretends that it's not because it makes decisions based on this. So our job is to bridge that gap and understand what decision-making machines should be. Cool? Does that make sense, Chris? Great question, great question. So this date is wrong. December 2013 should be October 2014. I went and checked. I just looked online. I actually have the old number up here. I checked Zillow again, and when I checked it, I forget what day it was a few days ago. At the time I checked it, there were 30,148 homes up for sale on Zillow. That's all of them. At that moment I checked it, that's all of them. Of those, 586 were in foreclosure. 586 were in foreclosure at that moment. Okay? So the question I have now is, how does the state of Oregon's overall foreclosure rate compare to Bend's? It's a lot lower. What is it?
1.94.
The 1.94%. So you took the, I'm guessing you took the 586 divided by the 30,148. All right. How about the margin of error?
There is a,
Boom! You don't need a margin of error when you have a parameter. Isn't that little p? That's why I put on a sample, exclamation point. Assuming Zillow has all the houses properly listed in its register there is no margin of error. Error implies uncertainty. If I've got all the houses, there's no uncertainty. Even if I had like 99% of the houses, the margin of error would be so small it'd essentially be zero anyway. But this is the assumption is they're all there. So yeah, the question is there, now we'll be with this MMD in a second, we'll understand what that means. So we know, let's swing this guy over here, and let's add our parameter to our statistics. We didn't use red? There, thank you. So October 2014, we know that little p, not p hat, little p, is 586 out of 30,148. Which comes out to be, what was that percentage again? I'm sorry.
1.94.
0.94.
1.94.
Where does that live? Ooh. Yeah, ish. Right there. And that's even too wide, isn't it? By drawing lines up and down, I gave it width. It shouldn't even have width. The question I have now is, we had the question, it's much lower than Ben's. Love that. Perfect. Much lower than Ben's. My question is, how much lower? How much lower? For example, how much lower is it now than it was in December of 2013? Now, this is not an answer you can give me with certainty, but you can give me a minimum measurable difference, can't you, at 95% confidence? That's what MMD stands for, minimal measurable difference. There is a difference, clearly, correct, between that number and that blue interval. Is that fair? You guys buy that? I'm going to draw the line a little bit longer so it spans all three of them. There is a minimum measurable difference. What is the minimally measured distance between that line and that blue interval?
3.86.
I hear 3.86. How do we get that?
Subtracted the 5.8.
This number here, minimally, was at 5.8%. You might remember that from your last calculation. If you didn't, you can always recalculate it very quickly. That's what's nice about technology. This right here is 5.8%. That's the low end of our confidence interval. We're 95% sure it's at least that. If we're 95% sure it was at least that in December of last year, the distance between that and where the state of Oregon's is at 1.9% is simply found by looking at that the distance between them, which is almost 4 percentage points, right? Just about, just shy, 3.9% as I believe it was. All you gotta do is figure this out right here. That's the minimum measurable difference. In this case, about 3.9%. So if you've ever listened to a news report when they report on that, oh, it's dropped blah, blah percent. I assume they did it this way. They probably didn't, knowing the news, but I may give them the benefit of the doubt until I prove otherwise. They do it this way. They look at a point estimate or an interval, compare it to a second interval, and see how far apart they are, if they're apart at all. Are there any minimal measurable differences between these three confidence intervals here? Are there any? No, there can't be, because that implies they're actually not touching each other. The only way to have an MMD is to have them not touching each other, because that would be the difference. So the only difference that we can measure is between Oregon's rate in this 2014 to any of those intervals before. That's the only thing we can do in this particular case, unless you went back and did point estimates from somewhere else. But based on these four things we measured right here, 3 statistics and a parameter, we're limited to that with our conclusion. Ask me questions. Ask me questions.
So the question is asking for us to compare the rate to Ben's and leaves it open-ended? Like
Sure, absolutely. So, and really all I wanted you to do was for the rate, was just give me the 3, or whatever it was, the 1.9%. So Ben's in 2013, the minimum difference is 3.9%. Ben in April 2013, it's much different, it's higher. Ben's in January 2010, it's also different. So that's all I'm asking. I wanted you to make sure you know what an MMD is. So the question is, any MMDs? Yes, there are minimum measurable differences. I'm looking mostly for the fact that you didn't apply a margin of error to it. That's the big takeaway from that right there. The percentage is 1.9%. And that's it. You're done. It's 1.9%. That can be different than the 3 bend intervals. So all I'm looking for, as far as the points go, I see what you're saying with the points. As far as I'm asking for the points, the rate is 1.9%. Boom, that's 2 points right there. I want you to understand what that MMD means and how you can actually use the integrals to calculate that. And we're going to get back into that here with the rest of the class together as well. Is that fair, Ben? Make sense? Fair? Connor, go!
Are we 95% sure that the MMD is that number?
We have to be, because this is 95% sure. Can I answer that question again in like 3.5 minutes?
Awesome.
Because that starts to shrink when you start putting more and more intervals in. And that's an idea I want to keep coming back to and coming back to. That's very, very powerful. Here, we're 95% confident because that one's 95% confident. And this one is
Solid.
solid, 100% solid. So, in which case, we've got plenty of confidence, as much as we've had in the first interval. If we had 2 parameter values, if, for example, I counted every house in December of 2013 and every house in December of 2014, then I'd have 2 vertical lines. How confident would I be there?
100%.
100% solid, right? No uncertainty. As soon as you have uncertainty, it drops. The more uncertainty, it cumulatively drops. So I want to re-answer that with some news headlines I've collected for us up here. We'll get to that momentarily. Other questions? That was a great one, thank you. Good? Goodish? Goodish. Goodish. Let's take a trip down using the PowerPoint here, and you'll have access to this PowerPoint. I think you already do. I think I linked it on Tuesday. If I didn't link it on Tuesday, I'll link it today.